So, have you looked into how Go handles concurrency with channels? I mean, it's quite elegant compared to mutexes in some languages.
Yeah, the channels make sense for managing data flow between Go routines without much overhead.
Exactly. And unlike mutexes, channels don't require explicit locking and unlocking. You just send and receive values, which makes your code cleaner and easier to reason about.
But what about performance? Mutexes can be faster when you're dealing with simple critical sections.
True, but the simplicity of channels often leads to fewer bugs and more maintainable code over time. Plus, if you're using a mutex wrong, it can lead to deadlocks or race conditions that are hard to debug.
That's true. It's all about trade-offs between safety and speed.
Absolutely. And let's not forget that Go's runtime handles scheduling for us automatically. With channels, you don't need to worry about spinning up threads manually like you might with mutexes in other languages.
Right. The scheduler takes care of balancing the load across available CPUs.
Precisely. And there's another thing, context cancellation. Have you seen how easily you can cancel operations using context with channels?
Oh yeah, that's really handy for cleaning up resources when an operation is no longer needed.
Speaking of which, there are some use cases where channels really shine over mutexes. For example, when you have a producer-consumer scenario, channels are perfect for managing the flow of data.
Definitely. Especially since channels inherently handle synchronization between producers and consumers.
Exactly. Another case is when you want to implement non-blocking operations. Channels can be used with select statements to avoid blocking indefinitely while waiting for a result.
That makes it easier to write responsive applications without worrying about getting stuck in a deadlock.
True. And think about fan-out scenarios where you need to broadcast messages to multiple subscribers. Channels can do this very elegantly by having multiple receivers.
Right. That would be cumbersome to achieve with mutexes alone.
Absolutely. Also, consider error handling. With channels, you can pass errors along with regular data, making it straightforward to propagate and handle errors across different parts of your program.
That simplifies error management significantly compared to checking locks and conditions everywhere.
Yeah, error handling with channels is much cleaner. Now, let's talk about performance. Mutexes can be more efficient in scenarios where you have tight loops and minimal contention because they involve less overhead.
True, but that efficiency comes at the cost of increased complexity in code maintenance and debugging.
Exactly. Channels might introduce some overhead due to message passing, but they often lead to more predictable performance in concurrent systems. Plus, they can help avoid bottlenecks by distributing work more evenly.
That's a good point. In highly concurrent environments, the simplicity of channels can outweigh the slight performance hit from message passing.
Agreed. Also, consider the context switching involved with mutexes. If you're frequently acquiring and releasing locks, it can add up in terms of CPU cycles spent on context switching.
Right. So channels might perform better in those cases because they reduce the frequency of these switches by managing data flow more efficiently.
Absolutely, reducing context switching can make a big difference. Speaking of which, let's talk about deadlock prevention. Channels in Go have some built-in mechanisms that help prevent deadlocks, right?
Yes, using select with default cases can help avoid blocking indefinitely, and thus prevent certain types of deadlocks.
Exactly. The default case allows you to specify what should happen if no channel is ready for communication. This can be crucial for keeping the program responsive.
And the use of context with timeout or context with deadline can also help manage timeouts effectively, ensuring that operations don't hang indefinitely.
True, integrating context with channels provides a robust way to handle timeouts and cancellations gracefully. It's much harder to achieve this level of control with mutexes alone.
Definitely. With mutexes, you'd have to implement additional logic to handle timeouts and ensure that all locks are properly released.
Exactly. which adds complexity and increases the risk of bugs. Channels simplify this by providing a higher-level abstraction that naturally supports these kinds of operations. Indeed, channels provide a simpler way to handle timeouts and cancellations. Now, let's shift gears a bit and talk about mutex contention. How does it impact performance in highly concurrent environments?
Mutex contention can really slow things down. When multiple coroutines try to acquire the same lock simultaneously, it leads to waiting times and context switches.
Absolutely, and if the critical section guarded by the mutex is small, the overhead of acquiring and releasing the lock can become significant compared to the actual work done inside the critical section.
That's why in such scenarios, using channels to manage data flow can be more efficient, because they don't introduce this kind of contention.
Exactly. With channels, each coroutine can operate independently until it needs to communicate with others through a shared channel. This reduces the likelihood of contention and improves overall throughput.
And when you have many readers and writers, channels can distribute the load more evenly compared to centralized locking mechanisms like mutexes.
True. The distributed nature of channels means that even if there's some delay due to message passing, it's generally less impactful than the delays caused by frequent lock acquisitions and releases. Right. The distributed nature of channels helps with load distribution. Let's talk about synchronization between coroutines using channels. How effective is it compared to traditional methods?
Using channels for synchronization is quite effective. They allow coroutines to wait on specific events or data without needing explicit locks.
Exactly. Channels provide a natural way to synchronize based on data availability. For example, you can use a channel to signal completion of a task, and the receiving coroutine can proceed only after getting that signal.
That's a lot cleaner than setting up and checking mutexes or condition variables.
Absolutely. With channels, you can easily set up complex coordination patterns, like waiting for multiple signals before proceeding. You can use sync, wait group combined with channels to manage multiple tasks effectively.
And because channels are first-class citizens in Go, they integrate seamlessly with other language features, like closures and deferred functions.
True, and this makes them versatile for various synchronization tasks. Whether you're coordinating simple sequences of operations or more complex workflows, channels offer a flexible solution that's both readable and maintainable.